Good morning, everybody. As we move on into this new week, we are going to be talking about stars. Incidentally, on the news this morning, I did hear that the massive black hole in the middle of our galaxy is now thought to be about 2,000 light years closer than was predicted. Used to be, we thought we, meaning the Earth, we're about 27,000 light years from the center. Now it's pushed to 25. Doesn't really mean much, but astronomers are thinking that our solar system and our galaxy is moving a little faster than they thought. What this means, who knows? But it was an interesting story this morning. Speaking of interesting, let's talk about stars a little bit this morning. Stars are a little like humans in the fact that they are born, they live, and they die. Whether or not a star becomes just a typical, normal, everyday, a kind of a, I won't say boring, not at all, but a regular existence, or whether the star goes and becomes a gigantic red supergiant and goes to a supernova, that particular path depends upon one factor, and that is mass. The mass of the star will determine which path it goes. Our sun, as you probably know, is an average sized star. It will someday expand to become a red giant. We'll talk about why that is in a little bit later on. And it will expand out, throwing out all of its elements into what is known as a planetary nebula. And you remember the term nebula, a large cloud of dust and gas in space. And then eventually our sun, our star, will fade away very quietly into a white dwarf. So no nova, no supernova, not for our star. It's just an average sized star. Again, a more massive star is going to produce a much greater energy. It will become a red supergiant. That star will then go to a supernova. And once that's over, it can go to a neutron star, or it can become a black hole. But again, mass is the key. One thing you need to know about stars is they are in a constant internal battle. The star would love nothing more than to take all of its massive gravity and crush itself. However, inside, in the core, you have a lot of nuclear reaction, nuclear fission, fusion going on. And so that fusion produces a tremendous amount of pressure that's pushing outward. The gravity wants to crush the star. The pressure on the inside produced from the energy in the fusion and the core, that is continually pushing up and out, and that maintains a balance, and we call that stellar equilibrium. Stellar as in star, equilibrium as in balance. One of the things we will learn about stars is that stars produce elements. The most common form of fusion in a star is the fusion from hydrogen into helium. And that lasts for a pretty good time here, 7 times 10 to the 6th years. But once the hydrogen runs out, the star is going to have to do something, so it starts to fuse helium into carbon. When the helium runs out, it starts to fuse the carbon and produce oxygen, oxygen to silicon, silicon into iron. Once iron shows up, that is the end of the road. Once iron shows up, in about 1 day, the core will collapse, and that's it. So when iron starts to be produced in a star's core, that is the beginning of the end. Now, when stars occur within a nebula, you may remember that, when rotation, temperature are adequate, a protostar forms. And we also know that stars, their temperature and color are going to be very, very important. And we're going to talk a lot more about that a little bit later on. But for now, that kicks off the idea that stars are gigantic nuclear engines, and the mass of the star will determine the path that it takes. That's all for now. You have a great day, and I'll talk to you soon.